Okay, again here I'm going to do these two different ways. First one here, I'm going to multiply everything by my common denominator. And if you look here, I have an x plus 2 and an x plus 2. So my LCD is just x plus 2. Check to make sure we don't have any restrictions. Subtract 2. X cannot equal negative 2. And I'm going to take and multiply everything by my LCD. Again, the idea there is that if I multiply both sides of my equation, it stays equivalent, and I can simplify. X plus 2 divided by x plus 2 is 1. X plus 2 divided by x plus 2 is 1. All I have left is x minus 1 equals x squared plus 2x minus 3. I could have factored my numerator there, but that wouldn't have been super helpful because I'm going to have to FOIL it back to distribute before I combine my terms, and I already had a common denominator. So I knew there was nothing I was going to be able to simplify until I got rid of my denominator. So it's called clearing your fractions. And that's what we did when we multiplied by the common denominator. If we look, there's nothing left in our denominators. Everything canceled. Now, I need to go ahead and, since it's quadratic, get it set equal to 0 by subtracting an x and adding 1. So I get 0 equals x squared plus x minus 2. Factors here, plus 2 minus 1, multiply to 2, subtract to 1. Bigger number always gets a sign in the middle. I set my factors equal to 0. I get x equals negative 2 and x equals 1. Again, we have to check our answers. When I check, I know that x can't be negative 2. So I can just check 1 here. 1 minus 1 over 1 plus 2 equals 1 squared plus 2 times 1 minus 3 over 1 plus 2. I get 0 over 3 is 0. I get 1 plus 2 minus 3 over 3. 1 plus 2 is 3, minus 3 is 0 over 3, which is 0 equals 0. So that checks. And I get just x equals 1. The second option is to simplify each side of my equation first and then use proportions. In order to do that, I need to get my common denominator. My LCD here is x plus 1, x plus 4. For my two different fractions, those are my denominators. My least common denominator is the product of all of my prime factors the most number of times they happen, which is 1 for both of those. This right here is my LCD. Since I have my denominators already, I might as well find my restrictions. Here I have x cannot equal minus 1, minus 4. So keep that in mind as we go. Okay, now that I have my common denominator, I need to write equivalent fractions. I have the x plus 1. I'm missing the x plus 4. So I'm going to go ahead and multiply by x plus 4. And whatever I do to one part of my fraction, I do to both. Second one here, I have the x plus 4. I'm missing the x plus 1. So I'm going to go ahead and multiply by x plus 1. My equivalent fractions are going to be x times x plus 4 over x plus 4, x plus 1, plus 3 times x plus 1 over x plus 4, x plus 1. Now, distribute. And combine as one fraction. Once I have the same denominator, I can perform the operations on my numerator here, just adding. So I have x squared plus 4x plus 3x plus 3, and write it over my denominator. I'm going to simplify here. X squared plus 7x plus 3 over x plus 4, x plus 1. Now, I've completely simplified the left side, and now I need to get my right side to match. Get a common denominator if I can. Between the common denominator I have already and x plus 4, my denominator is going to be my common denominator that I have currently. So I have the x plus 4, I'm missing x plus 1. So I multiply top and bottom by x plus 1. Just going to rewrite this one more time over my LCD. Here I can FOIL x squared plus x plus 3x plus 3 over my LCD. And I switched it to writing it over LCD for two reasons. One, to save time, and two, because I know those are the same. So it does not matter what they are, because if my common denominator is the same on both sides of an equal sign, then my numerator has to equal numerator. It doesn't matter what we divide by. If it's the same, in order for it to be equivalent, both of our numerators have to be equal. So x squared plus 7x plus 3 equals x squared plus 4x plus 3. Go ahead and move your variables together by subtracting. I'm going to move to the left. It does not matter. And we move from one side to the other by doing the opposite. So instead of adding, we subtract. Three x equals 0. Divide by 3. And I get x equals 0. That's not one of my restrictions, so it looks like it might be okay, but let's plug it in just to check. We get 0 over 0 plus 1 plus 3 over 0 plus 4 equals 0 plus 3 over 0 plus 4. 0 over 1 plus 3 over 4 equals 3 over 4. 0 divided by anything is 0. So when we add those, we get 3/4 equals 3/4. It checks. So our answer here is just 0. I'm going to bounce around a little bit and go to example 3 now. Example 3 in the book wants you to use a graphing calculator to solve rational equations. We don't have graphing calculators, so I'm not going to use them. I'm just going to keep solving them the same way, just to get a little bit more practice and a couple more examples for you to see here if you need. Again, we're going to get a common denominator. And it does not matter to me which way you solve them at all. Doesn't matter. So whether you get a common denominator and multiply everything by your common denominator, or if you combine your fractions on each side and use proportions, that's just fine. Doesn't matter for me. Okay, least common denominator here. I'm going to go ahead and solve this one by multiplying by my common denominator. So here I'm going to multiply by x plus 2, x minus 2. And again, we do that to every term in our equation. X plus 2, x minus 2. And I wanted to do that to show you here what would happen with that whole number. So on the left side, my first fraction, my first rational expression there, x plus 2 divided by x plus 2 is 1. It leaves me with 2x minus 2. X minus 2 divided by x minus 2 is 1, which leaves me with x times x plus 2. Here I just have 1 times. I have nothing I can cancel out, so I leave it as x plus 2, x minus 2 times 1. We don't need the 1 there. Okay. Go ahead and simplify this. This is just like any other time where we've had fractions. To get rid of fractions, hey, we don't necessarily like fractions, most of us, so we get rid of them by clearing them. And in order to do that, we multiply by the common denominator. So I'm going to simplify and solve here. Distribute 2x minus 4 plus x squared plus 2x. Again, all I did there was distribute. On the right side, I'm going to FOIL. X squared minus 2x plus 2x minus 4. I'm going to combine like terms on the right. X squared plus 4x minus 4. On the left, I'm going to do the same. X squared minus 2 plus 2 is 0, minus 4. I did not check for restrictions over here. It's going to be positive 2 and negative 2. If I added 2 here, subtracted 2 there. Okay. Now, because it's quadratic, I'm going to try and get it set equal to 0. I also need to get all of my like terms together, and in order to do that, to move from one side to the other, I have to do the opposite. X squared minus x squared is 0. Negative 4 plus 4 is 0. Negative 4 plus 4 is 0. X squared minus x squared is 0. I get 4x equals 0. Divide by 4. And x equals 0. It's not in one of our restrictions, but we do want to plug it back in and check just to make sure. 2 over 0 plus 2 plus 0 over 0 minus 2 equals 1. 2 over 2 plus 0 over negative 2. 2 over 2 is 1, plus 0 divided by negative 2 is 0. 1 equals 1. It checks out, and x equals 0 is our answer. I'm going to stop this video here and start the next one.